Good morning and welcome to the New South Wales Science and Research Breakfast Seminar today. This one is entitled The Science of Bushfire Risk and will be presented by Senior Professor Ross Bradstock. In welcoming you this morning, I'd like to acknowledge the traditional owners of the lands we're on. I'm on the land of the Gadigal people of the Eora Nation, and I'd like to acknowledge their elders, past, present and emerging. Maybe you'll be surprised to see me. I'm Mary O'Kane, I'm the former Chief Scientist and Engineer, and I suggested to Hugh that I introduce today's seminar because recently I, along with Dave Owens, have led the New South Wales Bushfire Inquiry, which is currently being considered by the government. Just before I introduce Ross, I'd like to do a couple of housekeeping things. The seminars continue to be online due to COVID, but the Office of the Chief Scientist and Engineer is in frequent contact with Parliament House, and the minute that the seminars can be moved back to Parliament House, you will be informed about it. If you want to put a question to Ross today, please send your question to breakfastseminars@mediahouse.com.au and I will read them out at the end of the talk. I particularly want to say a few things about Ross Bradstock because in doing the New South Wales Fire Inquiry, I discovered that we're blessed here in New South Wales and more generally in Australia with fantastic people in the science of bushfire. We've got really deep knowledge and very creative knowledge about what is going on. And the real leader of this is Ross Bradstock. Ross, for a long time, has been the director of the Centre for Environmental Risk Management of Bushfires at the University of Wollongong. But he also is the director of the New South Wales Bushfire Risk Management Research Hub. The hub is a wonderful invention. It's a mixture of researchers and bureaucrats. It's led by Ross, funded by the New South Wales government, and it helped us tremendously in our work on the Bushfire Inquiry. It helped us not only to understand what are the causes of the fires, why they act like they do, why they destroy things, but it also helped us to pose the big questions we needed to pose under the terms of reference we were given by the government. And I'm very grateful, Ross, to you and to everyone in the hub for all the work you did and to your incredible leadership in helping us. I'm sure we're all grateful across New South Wales and more generally Australia. Ladies and gentlemen, please welcome Ross Bradstock.
Thank you very much, Mary. I'll summarise the material that I'll present, which is wide-ranging and challenging, but hopefully very interesting. We're going to address a range of questions this morning. Briefly, what is the significance of fire? What is bushfire risk? How much risk can we mitigate through our management actions? What happened in 2019-20? An obvious question that everyone wants to know about, and what does it tell us, particularly about the future? And finally, I'll address the topic of the future. Can we peacefully coexist with fire? Fire is a complex phenomenon. To understand it, you have to study a bit of biology, physics and chemistry. It's the interaction of all those things, literally the aerobic combustion of biomass. Notice also that this burning leaf is being held by someone. You can see the fingertips, and fire inherently involves people. Fires occur all over the world. Here's a map of fire activity in the last couple of decades, and you can see the concentration of fire illustrated by the brown tones in Northern Australia and through equatorial Africa. All continents experience fires, or currently experience fires, except Antarctica. So fire is a common issue that we share with people from all over the world. Fire is of deep antiquity. Fires have been around for hundreds of millions of years, ever since land plants evolved. Some of the adaptations we see, such as these resprouting leaves on eucalypts, are now thought to have evolved under the influence of fire and may be of the order of 50 million years old in terms of their origin. Of course, fires can very adversely affect human communities. So a couple of years ago, there was a major set of fires in Greece, which caused many fatalities and people to flee into the ocean in coastal towns. And that's eerily familiar to the experience of many Australians in the last fire season. But on a more positive side, people have been intimately involved in the usage of fire. Aboriginal people in Australia have been managing fire and using fire in order to survive for millennia. And we can learn and frame our relationship with fire using this type of experience. Fire and the study of fire and the management of fire has been revolutionised in the last 2 to 3 decades by new technology such as satellites, spatial analysis, statistical and computing power. Unimaginable things are now possible in terms of the science of fire and applications into management as a result of this revolution. Here we have the MODIS satellite, which is now fundamental in terms of mapping fire globally. MODIS satellite is a product of NASA. So, for example, now we can see patterns of fire size, duration, and speed of travel across the world over time, as shown in this slide. Closer to home, we can map the severity of major fires. Here is the extraordinary Gospers Mountain fire from last summer. We can use satellite information, remote sensing, to map the patterns of burning and the severity of burning, in other words, the degree of consumption of the forest vegetation across this landscape. And this is extraordinarily useful in terms of not only scientific analysis, but ongoing management and monitoring. The very same sensors in satellites can be mounted onto aircraft. So now the Rural Fire Service uses aircraft scanners to monitor and map actively spreading fires. And that informs decision-making, operational decision-making during emergencies. But that's also an incredibly rich source of scientific information, which is now being utilised. And here we have an analysis of the spotting phenomena that has been facilitated by the use of this extraordinary information. The revolution in fire science and management that is afforded by technology is ongoing and rapidly developing, and will enable us to meet the challenge in an ever more fulsome way. So what is bushfire risk? What do we mean when we talk about bushfire risk? The terminology and definitions of bushfire risk are relatively recent. There was a major inquiry conducted in 2004 under the auspices of COAG, and that provided one of the first tangible and clear definitions of risk, which is now commonly used through the fire science and fire management community. The definition there discussed the rather confusing terminology that's used. Terms like threat, hazard, and likelihood are often used interchangeably, but it did provide a definition of risk that affords measurement and quantification. So risk is the chance of something happening. So chance, the chance of something happening that will have an impact on objectives. It is measured in terms of likelihood and consequence. And I'll define what that means in a few moments in a little more detail. We are now in the risk management era, so risk management plans are commonly produced in different jurisdictions. And in those plans and other risk management, bushfire risk management initiatives, there is often discussion of risk to multiple values, so people, property and environmental values, infrastructure and other assets, etc. Risk planning now attempts some formal estimation of risk, and modelling technology and other lines of evidence, as well as expert opinion and local knowledge, are being used to try to formulate an overview of risk in such planning initiatives. A number of questions arise. Can risk be eliminated? If not, how much can be mitigated? What are the constraints and challenges? And most importantly, how much does it cost? If we examine a peri-urban development, such as here on the northern side of Sydney, we can sort of frame the problem and our approaches to mitigating risk. So likelihood is the chance of a fire starting, generally somewhere out in the landscape, can often be quite close to the edge of developments. The fire then spreads and there is consequence. In the case of an urban development like this, consequence will be the chance of damage or destruction and perhaps injury and loss of life as a primary objective and focus for bushfire risk management and research. We do a whole bunch of things to try and mitigate the chance of this happening and the magnitude of the consequence. For example, we have fire danger rating systems, which are a reflection of dryness and the ambient weather conditions. And we use that to make decisions about total fire bans, warnings, evacuation, various other kinds of preparation on the day. We also know that fire danger is positively related to chance of fires occurring and the rapidity of their spread. We undertake all sorts of preventative activities. Prominent amongst those are fuel reduction, fuel manipulation, principally through the active use of fire, prescribed burning or hazard reduction burning. But there's also a network of trails and there's also mechanical treatment of vegetation and various other preventative activities. We undertake suppression. Once a fire has begun, suppression is traditionally ground-based, involving people and machines, but increasingly we are using aircraft and chemicals to impede the spread of fires once they have begun. And obviously, we also do a whole bunch of things that are associated with planning and which are intended to alter the vulnerability of our settlements and developments. I'll talk about those in a few moments. So let's just briefly examine the performance of some of these measures in terms of risk mitigation. And I want to just use some examples from published science to illustrate how much risk can be mitigated from some of these activities. One of the key things about understanding the preconditions for fire as encapsulated in fire danger ratings is landscape dryness, the dryness of fuel. Dryness of fuel determines its availability to burn. Here we've used satellite information to examine the live fuel moisture content of vegetation across the Sydney Basin over a number of months. This is a map of the moisture. Brown means critically dry Blue to green means wet. Critically dry means it's very available to burn. And you can see the dark and lighter brown tones changing as we went from October 2001 through to December. And in particular, you can see the landscape drying quite rapidly from November through to December, with large areas becoming critically dry and available to burn, as indicated by the dark brown patches. The black, the black shapes, or the shapes outlined by the black perimeters, indicate the areas burned by fires started through lightning on the 23rd of December, the Christmas 2001 fires, which had major impacts in the region. And you can see the general correspondence between those critically dry patches and where fires eventually burned. So this provides a near real-time monitoring capacity. The satellite information can be updated every couple of days, and it allows us to see how the dryness in landscape evolves. The big challenge is shifting from a near real-time monitoring capacity to more of a predictive capacity, which might allow us to see weeks and perhaps even months ahead how landscapes can become available to burn. Fuel reduction burning is a key management activity, and there's been a lot of work invested in trying to understand the effectiveness of fuel reduction burning and ultimately the effectiveness in mitigating risk. Here we've used computer simulation to synthesize a lot of our knowledge about fire behaviour and fire weather and the way in which fuel is altered through deliberate burning or prescribed burning, and how that translates through into a change in risk to critical assets such as houses and lives and the general area burnt by wildfire. So this is the results of simulation work for two landscapes, one on the western side of Canberra and one on the western side of Hobart. And on the vertical axis, we have what's called relative risk, just on a scale of 1 down to 0.4. 1 means maximum risk. And on the horizontal axis, we have the rate of treatment through prescribed burning per annum as a percentage of the landscape. And we can see generally that risk is reduced as you increase the treatment rate for each of these three variables. But there are differences in the response between the ACT case study example and the Tasmanian example. And that reflects differences in the biophysical context, the vegetation, the weather conditions that are inherent to those areas, as well as differences in human context, the configuration of houses, etc. These red arrows just indicate roughly the current treatment rate, around 2%, that current management achieves. And you can see that that corresponds to a modest reduction in risk that is being achieved through current approaches to management in these landscapes. So risk reduction or mitigation potential at the moment is modest. There's a lot of different suppression activities that are carried out on spreading fires, as I indicated before. Here's an example which examines different modes of suppression and different quantities of suppression. On the vertical axis, we have the potential for large or extreme fires. Obviously, at the top of the potential is high, and at the bottom it's 0. And in each panel, we have looked at ground-based suppression versus remote area fire teams inserted by helicopters, particularly in terms of initial attack on fires that have only just begun. And you can see differences in each panel. Each panel just represents different levels of prescribed burning in the study landscape, which was the Wollongong National Park area in the northern Blue Mountains. And you can see generally that remote area teams perform better in terms of potential suppression effects than ground-based suppression. It's a very rugged area. Ground-based suppression is difficult. And the doubling your remote area fire team capacity can also mitigate the chance of larger extreme fires. Suppression technology is changing very rapidly. We're now in the very large air tanker era. We're increasingly using fire retardant chemicals. But unfortunately, we know very little about the effectiveness in scientific terms of this rapidly evolving technology. We know that large sums of money are being spent, but there are enormous unknowns and big questions about the effectiveness of some of these initiatives, which need to be resolved through scientific research as a matter of urgency. In New South Wales, we have development controls in bushfire-prone areas which mandate construction standards and the way in which we manage the immediate environment around houses. A lot of this is predicated on theory, and there's research now which tests some of the critical aspects of our development control system. For example, work done after the Black Saturday fires in Victoria showed that the proportion of houses destroyed, the chance of a house being destroyed, was positively related to tree cover within 40 metres of those houses. And this is shown in the graph here. You can see that high levels of cover correspond to high chance of destruction. There are two lines here. The purple line simply indicates gardens that are predominantly native or composed of native species, and the blue line reflects the response of gardens composed of mainly of exotic species. And you can see exotic species lead to a lower chance of destruction. More recently, we've examined house destruction in New South Wales, which shows that the probability of damage and destruction is related to the density of houses. So the more widely spaced houses are, the lower the chance of destruction. But the probability of damage and destruction is also a function of a positive function of radiant heat flux. The theory of radiant heat flux underpins a lot of the stuff in our development control system. So this is empirical evidence that it actually works. Defensible space is particularly important, and that's primarily a responsibility of householders, and maintenance of this defensible space, gardens, garden condition, etc., is critical. And this sort of work provides evidence that building and development design can mitigate risk. We can conclude that risk to people and property is unlikely to be eliminated through any of these particular measures. We can ask the overarching question, what is the optimal risk mitigation investment strategy for any of these particular measures? In other words, how should we best invest our money to achieve maximum risk reduction per unit of expenditure, per dollar expended, if you like? We can also frame that question in terms of the totality of what we do. So each of the facets of fire management that I briefly described represents a potential choice. So how should we best distribute our money across the portfolio of things that we do? We have no real clear answer to that question as yet. It really involves drilling down and understanding the cost effectiveness in terms of risk reduction of each of these measures, and the stuff I've shown you provides some of that platform. We'll investigate that in a little bit more detail in a moment. We're not only interested in risks to people and property, but also environmental risk, biodiversity, crops and plantations, security of our catchments and water supply, and also other less tangible things like our amenity and recreation. These are all things that can be adversely affected by fire, in other words, consequence. And I'll briefly examine some of these. So arboreal mammals such as koalas and in this case the greater glider, threatened species, are obviously sensitive to intense fires, such as crown fires in forests, just through their life history and their inherent habitat. Work that we did some years ago on the Northern Ranges showed that even just one fire in a 30-year period significantly reduced the abundance of greater gliders. So that demonstrates the actual degree of sensitivity. And we can use fire severity information, such as for the Gospers Mountain Fire, as I mentioned earlier, to begin to estimate the potential impacts of such an enormous fire on populations of arboreal mammals. You can also see that the pattern of severity, in particular the dark brown and black areas, will be severities that will be highly deleterious to arboreal mammals. But we can see that the variation in severity is to some degree hardwired as a function of the topography in this very complex landscape. So that variability in severity provides some potential for refuges for arboreal mammals. We can say that those refugia are hardwired into rugged landscapes, the expression of the terrain and its effects on the severity patterns will provide that. Many species of plants, such as most of the eucalypts, which dominate our forests, are able to resprout after fire, but equally there are many species that can't resprout and they rely on their seeds for post-fire regeneration. So here's an example of a Banksia species that doesn't resprout. And species like these are sensitive to variations in fire frequency. You can have too much fire or too little fire, and either of those extremes may be deleterious to species like this. So we can examine over time the pattern of fire intervals, which is an expression of fire frequency across landscapes. And here we have an example in the Blue Mountains. And we can identify patches in the landscape where a species that is sensitive to fire frequency may be excluded either through too little or too much fire. You can see potentially across this landscape there are some significant areas where the fire frequency may be adverse. All that information can be used in management to see how we're tracking in regard to key elements of biodiversity and other environmental values. A question that often arises is management for reduction of risk for people and property. Is it necessarily adverse in terms of some of these environmental values, such as biodiversity? And that often arises in relation to discussion about use of prescribed fire. So if we're going to use prescribed fire to mitigate risks to people and property, is it necessarily adverse for aspects of our environmental values. This is the extraordinary Mount Solitary prescribed fire, which was carried out in May 2018, principally to protect property in the Upper Blue Mountains townships. We'll just briefly use this example, the example of this particular landscape, to examine the question above, particularly using cost effectiveness as a measure or as a way of answering this question. This is the Blue Mountains landscape from which that photograph or in which that photograph was situated. We can see potential burning blocks highlighted in the general landscape in the blue colour, and burning blocks close to the edge of developments highlighted in the sort of purple or pink colour. And there are many different permutations, many different burning strategies that are potentially possible, many different burning rates and combinations of blocks selected from these two categories. We've explored almost the full suite of possibilities using computer simulation for landscapes such as these, and we've also put in the costs of treatment and the costs of impacts and how those costs may change as we select different strategic options, and I'll show you some of the results. They look like this. Different treatment combinations are arranged along the bottom axis and cost is on the vertical axis. Don't worry about the particular treatment options. They're too complex to go into. However, what you simply need to know is, first of all, the top horizontal line indicated by the red star is the cost of doing nothing. In other words, no burning at all. And you can see immediately that actually some treatment options end up costing more in terms of the total cost, which is the top of the histogram bars, than doing nothing. The brown and dark green parts of each bar indicate the treatment costs, and the lighter green and pink parts of the bar represent the impact costs in terms of life loss and house loss. We can see also that there's a lowest cost, total cost option, which is indicated by the bottom horizontal line and the blue star. This gives us some comparative assessment of our potential strategic options in this landscape. Remarkably, the lowest cost option is not too far away from the strategy that is currently in place in this landscape. We can add in cost impacts on environmental values, which is reflected in this graph, and we can see that basically the relativity of the do nothing or lowest cost option doesn't change. So adding in environmental values into this cost effectiveness framework doesn't change the overall result, which simply means that initiatives or selection of strategies to mitigate risk for people and property is not necessarily in conflict with mitigation of risk for environmental values in this particular landscape. And you can look at this project, which was sponsored by the Bushfire and Natural Hazards CRC. You can examine these sorts of results at this web address. In fact, we can repeat the exercise for a whole bunch of landscapes. So the Blue Mountains landscape is here on the second row of results, and we can compare the outcomes for ACT, Adelaide Hills, Tasmania. Here the costs are relativised. You can just simply see from the colour patterns that the solution, the best solution in the Blue Mountains is not going to be the best solution in these different landscapes across southeastern Australia. That simply means that risk mitigation solutions, in this case achieved through use of prescribed fire, need to be tailor-made to suit the local human and biophysical context. There is no one-size-fits-all solution. This operation was done to protect lives and property. However, it had major air quality effects, particularly over southwestern Sydney. It caused exceedances in particulates, which are now known to be deleterious to human health. This is a major emerging issue, and there's a lot of controversy about the health impacts that ensue from use of prescribed fire. However, it gets more complicated. This prescribed fire undoubtedly saved houses and lives after the ruined castle fire ignited in late November 2019. So the intention of this prescribed fire was fulfilled last fire season. And we can ask the question, is the trade-off worth it? On the one hand, we put smoke over Sydney when this fire was lit, which had potential adverse effects on human health. But on the other hand, lives and property were probably subsequently saved. Also, the smoke that was emitted from the prescribed fire may have had a benefit, or the prescribed fire itself may have had a benefit in ameliorating the smoke from the subsequent wildfire. There's a very complex set of potential trade-offs going on here. Sort of outlays in terms of smoke, savings, health, lives and property are all mixed up in this. What are the benefits and trade-offs involved in doing operations like this when you approach it from this point of view? We don't have the answer to that question, and that's a major research challenge that the Bushfire Risk Management Hub is addressing. So what happened in 2019-20? Here's a picture of Cobargo on New Year's Eve. We know the devastation that occurred there. We know that these fires were extraordinary in terms of their size. So this little panel here shows the relative area of forest on the left-hand side burnt from 2001 to 2018 in Australia. Generally, the average is around 2%. And what happened in 2019-20 was we had close to 20% burnt. And we can see relative amounts in other ecosystems across Australia. We had a whole bunch of fire-induced thunderstorms or pyroconvective fires during the season, which was record-breaking. We know also from other work that in global terms, the extent or the proportion of forest burned, around 20% in Australia, is significantly higher than in other forest biomes in different continents for the last 20 years. So this is a globally unprecedented event in terms of the size of these forest fires. There was a lot of debate about the causes of this unprecedented set of fires in 2019-20. Climate change was one of the issues that was discussed in the media. We also had discussion about abnormal fuel levels being causative. Things like land management, I've nominated logging. There's been arguments about whether the fires are an outcome of either too much or too little logging. There was also a discussion about the causes of the fires. Were they the result of arson or primarily lightning, etc., etc., etc. A lot of public debate. So what do we know, and what does this tell us, particularly about the future? The Bushfire Risk Management Hub has examined trends, historical trends in fuels across New South Wales leading into last season. We are now able to predict or estimate fuel through work done in terms of consolidating our knowledge of fuel dynamics and how it relates to vegetation and other ecosystem factors. We use that to produce a chronology from 1990 through to the present for surface, elevated and bark fuels for 4 bioregions in which the fires occurred in the eastern half of New South Wales. And you can generally see the trends. There is variation across the last 30 years in each of these fuel components, and in particular we can see the effects of the 2002-2003 fires in southeastern New South Wales, the Alpine and Canberra bushfires. They depressed fuel loads for a number of years, those fires, and those fuels have recovered. But we can see also that as of the beginning of the fire season last year, that fuels in 2019 were not anomalously high compared to the previous decades. They were pretty similar. This means that it's unlikely that fuel is the primary cause of the extraordinary area burned by these fires. We have to look elsewhere. One of the obvious places to look is the fuel dryness and fire weather that shape the season. Using the sort of techniques I indicated before, here we're looking at dead fuel moisture content in December 2019, actually estimated from atmospheric dryness. And we can see across much of southeastern Australia the dead fuel moisture content across very large homogeneous areas was either the lowest on record or very much below average. And this is using a perspective from 1950. The place was seriously dry. And we can look at the Forest Fire Danger Index, which encapsulates not only dryness, but the ambient weather conditions, wind speed, temperature, humidity. And again, this is the synthesis for December 2019 from weather station data and gridded weather products from the Bureau of Meteorology. And we can see the Forest Fire Danger Index more or less across the entirety of the state and into Victoria and southern Queensland was the highest on record or very much above average. The fires were an outcome of record dryness and fire weather in time and space over this extraordinary season. We're all familiar with many of the human and environmental consequences. Over 3,000 properties destroyed, dozens of lives lost. But there are success stories, and we've begun to try and understand why some properties burned and why others didn't. We know that significant areas of rainforest burned, particularly in northern New South Wales in the first part of the season, but also on the south coast. Possibly up to half of the rainforest estate in New South Wales burned, though that needs confirmation through extensive field survey. But there are also amazing surprises. Here is a planted Wollongong pine on a property that has been burnt, but it's resprouting. This wasn't really expected. There's a hell of a lot to learn. We've only just begun the journey. There are many opportunities to use these fires to confirm what we know, to provide new insights and to test our knowledge, and there will invariably be surprises. One of the most significant impacts, of course, was the smoke, and there have been some studies completed already, which attempt to estimate the human health consequences of the 2019-20 fire season. In particular, this particular study, coordinated out of the University of Tasmania, estimates that there were 417 excess deaths through the incredible smoke pollution events that ensued, and thousands of hospital admissions as a consequence. What does 2019-20 tell us? We know that the fires were unprecedented historically in the forested regions of Australia, probably the largest fires at least since 1851 in southeastern Australia. They are unprecedented as forest fires globally. This study attempts to project fires through to the end of the 21st century for New South Wales using various modelling techniques. Here, fire is expressed as CO2 emissions. The sort of shade, or the faded line, is the projection through from the present to the back end of the century. The black line is actual estimation of emissions from fires in New South Wales, and you can see the result of the 2020 fires by the peak of the black line. That's simply saying that the fire season exceeded the projections of fire even at the end of the 21st century under the influence of climate change. That's frightening. In other words, the season was beyond even future projections of fire for this part of the world under climate change. So what do we do? What does the future hold? I've used the term peaceful coexistence because there's a great analogy with what happened during the Cold War. We had to live with the threat posed by nuclear weapons of destruction. And it's sort of a useful analogy in terms of bushfire management. We know the destructive power of major fires. How do we live with this, particularly if the season of 2019-20 is a harbinger of the future? We do a whole bunch of stuff. As I've alluded to, fire management has many facets. There's all sorts of technologies. They're changing. One of the responses to a season like the last one and the prospect of it all getting worse in the future is to do more of the same. More trucks, more aircraft, more intelligence, deployment of the military, more trails, more burning, etc. But we've seen an order of magnitude increase in fire over the last season compared to the preceding decades. And if that's going to become, if seasons of that magnitude are going to become more frequent in the future, will just more of the same be enough to cope? Possibly not. We may have to think out of the box. Things like aircraft, very large air tankers, etc., require control systems, bureaucracies, centralisation, etc. That's a necessity. You can't run this sort of technology without the appropriate systems to coordinate it. We have a Royal Commission going on into the arrangements at a national level for national disaster response and management. That's likely to recommend even greater centralisation, perhaps acquisition of powers by the Commonwealth, coordination amongst the states. And that's actually needed. For example, we need to have a national fire monitoring capacity to better build our understanding of what's going on so we can analyse stuff more seamlessly. However, we're coming up against a problem. Centralisation, the bureaucratisation of fire management, leaves a lot of people on the ground out there in exposed communities feeling disempowered People out there have knowledge and they feel as if they're not being listened to. This is a huge dilemma. How do we resolve it? In fact, the grassroots of fire management come from self-organisation, communities banding together to do something, to take action, to defend their livelihoods and their lives and property. Local people are interested in fire, and there are many fantastic initiatives to inform and empower people. We can't lose this. We have to ensure that people aren't left out. Information is the key. Apps like Fires Near Me and other social media are almost a victim of their own success. They are some of the keys to providing the knowledge which will enable people to act decisively. Personal responsibility and choice is a catalyst for coexistence, and our knowledge systems and the science behind that are useful in terms of resolving this potential dilemma. It's almost certain that we will need greater environmental triage. The Wollongong pine populations were saved through intensive intervention. This sort of program of work may have to be played out on a larger scale with a wider range of threatened species and other key environmental values in the future. I cannot emphasise strongly enough the need for basic field work. We need to get out there and have a better understanding of where our threatened species are and how they're responding to fire. There are vast gaps in knowledge that need to be filled and cannot be filled without basic field survey, which unfortunately has tended to languish in recent years. We mustn't forget that the fires were part of a wider phenomenon of drought, and drought in itself caused all sorts of incredible effects. All this dieback in our forests before the fires occurred. The drought and the fires are interlinked, and the resilience and recovery of our forests from the fires may be partly determined by the state of the drought and its impacts prior to the fires. We also know that drought had other effects like these. It created these amazing dust storms. Here we have a dust storm about to envelop parks. This has implications, for the functioning of our infrastructure, but also the health of our populations. So you combine dust with smoke. In other words, the fires and the drought are interlinked. We can't really understand the implications of the fires without seeing them within the context of drought. In fact, drought is probably the hammer of climate change that is going to reforge our ecosystems. Fire will be part of that. It's mixed up with drought. That's going to transform our ecosystems and the way in which we obtain our livelihoods and the way in which we coexist with them. Can we continue to live like this? This is a pleasant place to live, but it is also incredibly dangerous. This block of land was recently sold and advertised as being cleared, ready to build your dream home. However, the real estate propaganda did not indicate that the house that existed on this block had been destroyed in the fires. Should we really be rebuilding in some of these cases? We've got to get smarter about separating our developments from flammable bushland, and in fact we may have to face the prospect of staged retreat from dangerous landscapes. This is a very complex social and economic question, and there have been various attempts at achieving this which have failed. We know that defensible space around the fringes of our developments, our backyards and over the back fence, we know that through science is incredibly effective in terms of mitigating risk. Here we can see an example which has been physically cleared, mechanically cleared and maintained. There's a lot of scientific interest in optimising the design of defensible space, appropriate spacing of trees, ground cover, etc. However, that's not the end of the story. Even the best defensible space may occasionally fail, and as in this example in California in 2017, once fires get into developments, horrific things can ensue. And that's a function of the design of the development itself. Possibly in this case, we're looking at mass spread of fire due to construction standards and the density of dwellings. It's currently being analysed. Are we setting ourselves up for this sort of thing with the nature of our recent and ongoing developments around the fringes of some of our large cities, which are impinging into flammable bushland and grassland? This is a critical issue that needs to be examined. It's not just the bushland interface with development that matters, it's the nature of the development itself. Finally, let's not be afraid. We've got to try new things. Can we engineer our interfaces and defensible space with plants of lower flammability, water features, etc., which are biodiversity friendly? It doesn't just have to be mown, perhaps. We need to experiment, and we need the knowledge to underpin those experiments. Aboriginal people are offering their wisdom, experience in terms of fire management. That's a generous offer that we need to take up and explore. That will help us in terms of reconciliation and the sharing of knowledge based on ancient traditions. We'd be crazy if we don't take up this opportunity. I'll finish by acknowledging major funding sources and a whole bunch of people who've contributed to this work over the years. Thank you for listening.
A great presentation, and there are a few questions, and we're really pushing time, but I'll put one question, I think, out of the ones that have come in. I think we've got time for one. So it's, what is the right balance of the amount of prescribed burning and the consequent production of climate changing emissions, which exacerbate the fire risk and become counterproductive?
We don't know the answer to that question. For our local forested systems, we know in Northern Australia through extensive work in very different tropical savanna systems that shifting the fire season to the early dry season through prescribed burning has emissions benefits. For various complicated reasons, including the whole nature of fuel dynamics and the probability of fires, we have yet to see evidence that that potential can be fulfilled in our forested ecosystems in southern Australia. It's possible that as you ramp up the percentage of prescribed burning that you do every year, we may go into total emissions deficit. In other words, we end up emitting more, even though we're saving some emissions from wildfires. And as I say, that's we've had a look at this question some years ago, and that's an outcome of rather different field dynamics and fire probabilities in the south compared to the north. But it still requires more work. We're in our infancy in really understanding the emissions implications of prescribed burns and wildfires in our forests.
Yeah, thank you. Look, I will put one more question of that they're tumbling in a bit now. And this is summarising a rather longer question. But the essence is, are there other fire seasons prior to 2001 that rivaled 2019-20 in terms of area burnt?
No. From what we've seen and from what we understand, and please bear in mind our comprehensive ability to map area burned only goes back about 30 years in southern Australia. So from the 70s onwards, we have reasonable mapping. It's obviously getting better all the time. So our record keeping is constrained. However, we know that fire seasons prior to the 1970s, the big ones have been recorded, and we have some estimation of area burned. So we know, for example, in New South Wales, there were major fire seasons in the forested parts, the eastern parts, in 1926, 1939, 1957, 1967, 1980, etc. 1994, 2001 are high points. The information we have from those past seasons, despite the limitations in mapping, suggests that this season is up to an order of magnitude larger than the biggest seasons in the past in the forested environments. So to give you an example, we know that, about 1 million hectares burned in 2002, 2003 across Victoria and southern New South Wales. We are looking at close to 5 million hectares this season. Now, outside the forested areas in Western New South Wales and generally across the arid and semi-arid interior, there are much larger fire seasons. So we know, for example, in 1974-75, around 4 to 5 million hectares burned in the Western Division. But they are totally different systems. They are dominated by grassy fuels. Fire follows rain in those systems. Western New South Wales wasn't able to burn last summer because there was no fuel, because the levels of grass and herbage were very low as a function of the drought. There were some fires, of course, but they were relatively small. So you've got to compare apples with apples, not apples with oranges. That's why we have to frame the significance of the 2019-20 fires within the forested regions of the nation and within comparable forested regions across the world.
Thank you. That's great, Ross. And Ross, a big thank you for a wonderful seminar. I continue to learn things about fire from you.
And I'm happy to respond to some of the other questions. I can do that via email if you can forward them.
We will. And on behalf of everyone listening, Ross has been sent a little present, a history of the New South Wales coast that'll keep him away from fires for a bit, and a fine Hunter Valley Shiraz. Now, a quick ad for the next seminar on Wednesday, the 21st of October, and almost certainly will be online. Distinguished Professor Dae-Yong Yin from the University of Technology, Sydney, will present a seminar entitled Harnessing Light for a Healthcare Revolution. And if by some magic we're back in Parliament House, the Office of the Chief Scientist and Engineer will let you know. Thank you and goodbye.